Bismillahirrahmanirrahim. Assalamu alaikum dear students. I hope you all are fine. I am Amna Sadiq, working as subject specialist in mathematics at Divisional Public School and College Sahiwal. Today we are going to start our second unit. It's about the theory of quadratic equations. In this chapter, we will discuss about the nature of roots of the quadratic equations, their properties, the information we get from these roots, about cube root of unity. Today, we are going to discuss about exercise 2.1, question number 1 and 2. So what is a quadratic equation? A quadratic equation is an equation consisting of the polynomial of degree 2 with single variable. The general form or the standard form of the quadratic equation is ax square plus bx plus c equal to 0. In this equation, the coefficient of x square, that is a, should not be equal to 0 and a, b and c are real numbers. We have already discussed about the quadratic formula. The quadratic formula for the equation ax square plus bx plus c equal to 0 when a is not equal to 0 is x is equal to minus b plus minus square root of b square minus 4ac over 2a and a is not equal to 0. This expression minus b plus minus square root of b square minus 4ac over 2a is also known as the roots of the quadratic equation ax square plus bx plus c equal to 0. The quadratic formula is a useful tool for solving all those equations which can or cannot be factorized. We can say that it is the ultimate method to solve the quadratic equations. Our today's topic comprises of the nature of roots of the quadratic equations. On solving the quadratic equations, we get different kind, nature or characteristics of roots. As we have already discussed that the two roots of the quadratic equation ax square plus bx plus c equal to 0 are minus b plus square root of b square minus 4ac over 2a and minus b minus square root of b square minus 4ac over 2a. In both expressions, a should not be equal to 0. The nature of the roots of the quadratic equations are described by using discriminant. Discriminant is an expression b square minus 4ac. In this expression, we put the value of b, a and c from the quadratic equation and get some information. This information helps us to analyze the nature of the root. The nature of these roots minus b plus square root of b square minus 4ac over 2a and minus b minus square root of b square minus 4ac over 2a of the equation ax square plus bx plus c equal to 0 depends on the value of expression b square minus 4ac. And this expression b square minus 4ac is called the discriminant. And this discriminant is of the quadratic equation ax square plus bx plus c equal to 0 or the quadratic expression ax square plus bx plus c. Now we will find the discriminant of the following given quadratic equations. The first quadratic equation is 2x square plus 3x minus 1 equal to 0. When comparing it with the general form of the quadratic equation, that is ax square plus bx plus c equal to 0, we get a is equal to 2, b is equal to 3 and c is equal to minus 1. We know that the discriminant is equal to b square minus 4ac. Discriminant can also be written as DICS with a dot, which is equal to b square minus 4ac. Now putting the values of a, b and c, we get 3 square minus 4 times 2 times minus 1. On solving, we get 9 plus 8, which is equal to 17. So the discriminant here is equal to 17. Now for the second equation, here a is equal to 6, b is equal to minus 8 and c is equal to 3, which we get from comparing the given equation with the standard form of quadratic equation. We know that discriminant is equal to b square minus 4ac. When we put the values of a, b and c, we get minus 8 square minus 4 times 6 times 3. On solving, we get minus 8. It can be clearly observed that the discriminant of the given equations are different. 17 is a positive integer while minus 8 is a negative integer. This property helps us in determining the nature of the roots of the quadratic equation. Now we will discuss about the nature of the roots of the quadratic equation. The root of the quadratic equation ax square plus bx plus c equal to 0, where a is not equal to 0, are minus b plus minus square root of b square minus 4ac over 2a, and its discriminant is the expression under the radical sign, that is b square minus 4ac. We know that a, b and c are real numbers. Then we have 4 cases that helps us in determining the nature or the characteristics of the roots of the quadratic equations. In case 1, if the discriminant b square minus 4ac is greater than 0, that is a positive number, and this positive number is a perfect square, then the roots are rational and unequal. We know that in the quadratic equation we get 2 roots, and these 2 roots will not be equal to each other. In case 2, if the discriminant b square minus 4ac is greater than 0 and it is not a perfect square, means this positive number we obtained as a discriminant is not a perfect square, then the roots are irrational and unequal. In case 3, if the discriminant is equal to 0, means b square minus 4ac is equal to 0, then the roots are rational and equal, means the 2 values we get as a root should be equal. The last case is when the discriminant, that is b square minus 4ac, is less than 0, means a negative number, then the roots are imaginary numbers and they are the complex conjugates of each other. Now we will find the nature of roots of the quadratic equations and verify them by solving the equations. The first equation we have is x square minus 23x plus 120 equal to 0. in this equation. When we compare this equation with the standard form of the quadratic equation, we get a is equal to 1, b is equal to minus 23 and c is equal to 120. We know that the discriminant is equal to b square minus 4ac. Putting the values of a, b and c, we get minus 23 square minus 4 times 1 times 120. Minus 23 square is equal to 529 minus 480, which is equal to 49. Since this is a positive number, that is, the discriminant is greater than 0 and 49 is the perfect square of 7, so the root of this given equation x square minus 23x plus 120 equal to 0 must be rational and unequal. As discriminant is equal to 49, which is greater than 0, and 49 is a perfect square, so the roots are rational and unequal. Now we have to verify this by solving the equations. Considering the quadratic formula, x is equal to minus b plus minus square root of b square minus 4ac over 2a. Putting the values of a, b and c, we get minus times minus 23 plus minus square root of minus 23 square minus 4 times 1 times 120 over 2 times 1. On solving, we get 23 plus minus square root of 529 minus 480 over 2. Again, we simplify it, we get 23 plus minus square root of 49 over 2. The square root of 49 is equal to 7, so we get 23 plus minus 7 over 2. Simplifying it for the value of x, either x is equal to 23 plus 7 over 2 or x is equal to 23 minus 7 over 2. On solving, we get x is equal to 15 or x is equal to 8. Evidently, we can see that 15 is a rational number, 8 is a rational number, 15 and 8 are unequal, so the roots are rational and unequal. Now, the second equation we have is 2x square plus 3x plus 7 equal to 0. Comparing it with the standard form of quadratic equation, we get a is equal to 2, b is equal to 3 and c is equal to 7. We know that the discriminant is equal to b square minus 4ac. Putting the values of a, b and c, we have 3 square minus 4 times 2 times 7. On solving, we get 9 minus 56, which is equal to minus 47. As we can see that minus 47 is less than 0, means it is a negative number. So, we can say that the roots are complex numbers or the complex conjugates of each other. As the discriminant is equal to minus 47, which is less than 0, so the roots are imaginary numbers or the complex numbers or the complex conjugates. Now we have to verify it. We consider the quadratic formula, which is equal to x is equal to minus b plus minus square root of b square minus 4ac over 2a. We put the values of a, b and c and get minus 3 plus minus square root of 3 square minus 4 times 2 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 times On solving, we get x is equal to minus 3 plus minus square root of 9 minus 56 over 4, which is equal to minus 3 plus minus square root of minus 47 over 4. The square root of minus 47 means we have got an imaginary number. We can write it as square root of 47 times iota. So we have x is equal to minus 3 plus minus square root of 47 iota over 4. This plus minus means we have got two roots and they differ only with the sign. And this property in the complex numbers is known as conjugates. So minus 3 plus square root of 47 iota over 4 and minus 3 minus square root of 47 iota over 4 are the complex conjugates of each other. So we can say that the roots are imaginary and complex conjugates. Now let's recapitulate our today's lecture. Today we have discussed about the discriminant of the quadratic equation ax square plus bx plus c equal to 0, and the value of discriminant can be determined by the expression b square minus 4ac. This expression is obtained by the quadratic formula, and the quadratic formula we can observe that it is the number under the square root or the radical sign. This discriminant helps us in understanding the nature or the characteristics of the roots of the quadratic equation ax square plus bx plus c equal to 0. We can determine the nature and the roots without actually solving them. So we can define the discriminant as it is a value calculated from a quadratic equation. It is used to discriminate between the roots or the solutions of a quadratic equation. The discriminant is also represented by capital D, which is equal to b square minus 4ac. To use this expression, it is necessary for you to determine the values of a, b and c in the quadratic equation. And before finding the discriminant, you need to first write the quadratic equation in standard form. So you can determine or identify the values of a, b and c properly. To determine the discriminant, we have to follow three different steps. First, we write the quadratic equation into standard form. Second step, we have to identify the values of a, b and c. Then, at the third step, we substitute these values to b square minus 4ac. For example, if we have the quadratic equation x square minus 2x equal to 15, first of all, we write the quadratic equation in the standard form. After writing the quadratic equation in standard form, we identify the values of a, b and c. Then we put these values in the discriminant b square minus 4ac. As a result, we get d is equal to 64. This value can be used to describe the nature of roots of the quadratic equation. It can be 0, it can be positive, it can be a perfect square, it can be positive but not a perfect square, it can be negative number. Here we use the discriminants to find the nature of the roots. B square minus 4ac is greater than 0. It means if the discriminant is a positive number or a number greater than 0, then the roots are real and unequal. While we are saying the real numbers comprises of two types, rational and irrational. So, we have two cases here. If the number is a perfect square, if the number greater than 0 is a perfect square, then we have rational and unequal roots. And if the positive number is not a perfect square, then we have irrational roots and they are unequal. If b square minus 4ac is equal to 0, then the roots are real and equal. And if b square minus 4ac is less than 0, the roots are imaginary and they are the complex conjugate of each other. Let's have an activity. Keeping this table in mind, we will find the nature of the roots by the given discriminants. If the discriminant is minus 12, since minus 12 is a negative number and it is less than 0, so the roots are imaginary or the complex conjugate of each other. If the discriminant is equal to 0, then the roots are real and equal. In this case, the real number represents rational numbers. If the discriminant is 33, since 33 is a positive number, so the roots are real and unequal, and 33 is not a perfect square, so the roots are irrational and unequal. And now the discriminant is minus 64. 64 is a perfect square, but we are considering minus 64. And this number is less than 0, so the roots are imaginary and the complex conjugate of each other. When the discriminant is positive 64, it is a positive number greater than 0, so the roots are rational, so the roots are real and unequal. As 64 is a perfect square, so the roots are rational. Now the discriminant is minus 169. Since it is a negative number, so the roots are imaginary or the complex conjugate of each other. Now the discriminant is 121. 121 is a positive number and it is a perfect square of 11, so the roots are rational and unequal. Now, for your home task, complete the remaining parts of the question number 1 and 2 from exercise 2.1. Also solve example 1 and 2. My dear students, this is all from our today's lecture. I hope you understand our today's lecture well. If you need some further assistance, you can ask your respective teachers. Stay calm, stay safe. Thank you. Allah Hafiz.